For each of the following graphs, find the slope of the line and label if it's velocity or acceleration. Describe the object's direction, forwards or backwards, and its motion, speeding up, slowing down, moving with a constant velocity. So find the slope is step 1. So slope is rise over run. So I'm going to start here at this first start here. It's at 1 second, and I go forward 1, 2, 3 meters. And then, oh, just kidding. Counted up too high. 1, 2, 3. 1, 2 boxes, and then over 1. Up 1, 2 boxes, and then over 1. Up 2 boxes, over 1. So the slope is 2. All right, next thing. Label if it's velocity or acceleration. Now, you might be saying to yourself, Mr. B, why are we doing more graphing stuff? We just did a bunch of graphing stuff. What more can there be? These are a different type of graph. These are called velocity graphs. They're not position graphs. They're velocity graphs. And the reason is they're graphing, wait for it, velocity. And so they're graphing the velocity on the x on the y-axis and the time on the x-axis, not the position on the y-axis and the time on the x. So rise over 1 is change in y over change in x. And the change in y is velocity divided by the change in x, which is time. So it's velocity over time. Well, what concept is velocity over time? Acceleration. So the slope of these graphs is not velocity. The slope of these graphs is the acceleration, which is why we do these kind of graphs. The reason we do these kind of graphs is it allows us to find the acceleration. On the graph we did for the car, we could not find the acceleration because it was a curved line. We couldn't figure out what that curve value was. But if we were to plot the velocities instead of the time, if we were to plot the velocity of the car instead of plotting the position of the car, we could actually find this. We could actually figure out how much does the car accelerate. We could calculate it. So this is an example of that. All right, describe the object's direction, forwards or backwards. We're going to call that, so this was 2, we're going to call this 3. Okay, so notice that all of my velocities are negative. And yes, I'm sloping up. But remember, velocity's direction is the sign. So a negative velocity is backwards, a positive velocity is forwards. These are all negative velocities. Even though they're getting larger, they're still negative. Negative 7, negative 6, negative 5, negative 4, negative 3, negative, negative, negative. That means this is backwards. And the last part is to describe its motion, speeding up, slowing down, or moving with a constant velocity. So, I notice that my velocities are getting smaller. Yes, I know that you're used to thinking of smaller negatives as bigger, but negatives are just direction. They're not size. So, smaller negatives are getting smaller. So my velocity is getting smaller. That means it's going slower, which means it is slowing down. Okay, I want y'all to try B and C. I want y'all to try B and C. See what you can do with those. You're going to do the exact same thing. Okay, step 1, find the slope. Step 2, tell me is the slope velocity or acceleration. Step 3, tell me is it going forwards or backwards. Step 4, tell me what is it doing. Is it speeding up, slowing down, or going with a constant speed? So I want you to tell me what direction it's going in, as well as what it's doing. The reason I want you to do that for both of these is one is a position graph, one is a velocity graph. So one graph shows you position, one graph shows you velocity. They both look the same. So are they actually the same? Do they actually tell you the same stuff? Okay? So go ahead and do number 2 for me. See what you can do for that one. All right, draw the position and velocity graph for each of the situations. So I want you to draw, so just like up here, these were the same pictures for different situations. I want you to draw the same situation with different pictures. And you may have not noticed this, but that's actually what B and C are over here. B and C are the same situation, just drawn differently. One's a position graph and one's a velocity graph. So here's what these first ones look like. I'll do 3A for y'all, and you guys can finish B and C. So going backwards at a constant speed. So on a position graph, backwards is going closer to 0. Constant speed means the velocity doesn't change. The slope of a position graph is velocity, so we want the slope to not change. So it would be something like this. Okay? Going backwards on a velocity graph means negative velocities. And a constant speed means that it's not going to change. So it needs to be something like this.
We go over number 2.
Say again?
We go over number 2.
Sure. What was your question on number 2?
Oh, I just want to make sure I have it right.
I'll come and check them.
Okay.